life with you all. If you serve somebody breakfast, well don't know. And if they serve you breakfast, on a blapper, pick up your pen, let's solve some inequalities. Oh.
In our next question, we are asked to solve this inequality. And one thing I will say before we continue is that inequalities of this form should never be solved by cross multiplication. Avoid as much as you can cross multiplication. This method is one of the best methods that you could apply in solving this kind of questions. So let's go ahead into it. We have 1 on x minus 4 greater than x on x minus 6. So we send this to the left hand side. That will give us 1 on x minus 4 minus x on x minus 6 greater than 0. What's the LCM? You simply multiply the two denominators. That will give us x minus 4 into x minus 6. This divided this times that will give us x minus 6 minus x into this divides this times that, x minus 4 greater than 0. Simplifying the numerator will give us x minus 6 minus x squared plus 4x. And x minus 4 into x minus 6, all that greater than 0. So we have negative x squared plus 5x minus 6 and x minus 4 into x minus 6 greater than 0. And that can also be written as x squared minus 5x plus 6 and x minus 4 is x minus 6 greater than 0. Now when we solve this numerator, the quadratic equation in the numerator by factorization, we are going to have x minus 2 into x minus 3 and all that on x minus 4 into x minus 6. Greater than 0. Now, this is what we have after solving this, after simplifying this. From here, we're going to get our boundary values. Yeah, from here, we get our boundary values. So, our boundary values will be 2, 3, 4, and 6. 2, 3, 4, and 6. Like, what's x here? X should be equal to 2 here, x is equal to 3 here, x is equal to 4 here, and x is equal to 6 there. So with our boundary values, we would now come up with the possible ranges that we will check to see, where we'll check to see which range satisfies our inequality. So right now, let's get our possible ranges. We have 4 possible ranges. X less than 2, x lying between 2 and 3, x lying between 4 and 3, and x greater than 6. And x minus 6. So, as we did in the other video, we'll go rapidly this time. We pick any value in this range, any value less than 2. For example, 1. 1 minus 2 is a negative value. 1 minus 3 a negative value. 1 minus 4 a negative value. 1 minus 6 a negative value. We have the table that has the product of all our solutions. So the product of all these is a positive result. Now, we pick any value in this range, any value between 2 and 3. For example, 2.5. 2.5 minus 2, it gives us a positive value. 2.5 minus 3 is negative. 2.5 minus 4 is negative. 2.5 minus 6 is negative. So, multiplying this will give us, at the end, a negative solution. Now in this range, let's pick a value. For example, 3.5. 3.5 in this range will give us a positive value. In this solution, 3.5 minus 3 will still give us a positive value. 3.5 minus 4, a negative value. 3.5 minus 6, a negative value. And so the product of this is positive. Now in our last range, let's pick a value. For example, 7 is greater than 6. So 7 minus 2 is positive. 7 minus 3 is positive. 7 minus 4 is positive. 7 minus 6 is positive. And the product of all that is positive. So in our question, we have the inequality greater than, meaning what? Positive. So the range that satisfies our equation is every positive range. And so we have this, this, and this. So this is the range, or these are the ranges that satisfy this inequality. So answer is x, such that x is less than 2 union 2 less union 3 less than x less than 4 union x greater than 6. These are answer. In this question, we're asked to find a set of values for which x plus 3 on x minus 1 in the modulo sign is greater than x plus 3 on x minus 1. This question is very interesting because normally to solve questions of this sort, you can go by squaring both sides. You square both sides and then you carry the expression on the right hand side to the left hand side, and then you solve it by the LCM method as we did the last time. But in this particular case scenario, if you square both sides and you send what you have on the right hand side to the left hand side, you realize that everything will boil down to 0, because what is on the right hand side, like what is within the modulo sign, is the same as what is on the left hand side. So how do we solve this kind of inequality? It's so interesting. We're going to go by the definition. Now, what's the definition? The definition of a modulo states that it will have x like this. This can either be equal to x when this is greater than 0. When what you have within the modulo sign is greater than 0, or this should be equal to negative x when what you have within the modulo sign is less than 0. So this is a principle that we will use to solve this kind of inequality. So going by this first definition, if this is greater than 0, then the magnitude of x plus 3 over x minus 1 will be equal to x plus 3 over x minus 1. So we are going to substitute this in this inequality for our first option. So you have x plus 3 on x minus 1 greater than or equal to x plus 3 over x minus 1. Let's send this to the left hand side. We have x plus 3 over x minus 1 minus x plus 3 over x minus 1. This is equal to 0. This minus this, it will give us 0. So this option 1 is meaningless. It gives us 0. Now let's try the next option. What does this give us? Negative 2x plus 3 over x minus 1 greater than or equal to 0. So from here, our boundary values are negative 3 and 1. Negative 3 and 1. So those are the boundary values that we use, come up with possible ranges, and then verify the set of values that will satisfy this inequality. Our boundary values are negative 3 and 1. Our possible ranges are x less than or equal to negative 3, x line between negative 3 and 1, and x greater than or equal to 1. So let's quickly check it at table. Which range satisfies our inequality? X less than or equal to 3, x line between negative 3 and 1, x greater than or equal to 1. Our first solution is x plus 3. Next solution is x minus 1. I have the product of these two solutions. Now, if we pick any value from this range, x less than or equal to 3, and we substitute it in this equation, what do we have? We'll pick something like 2, it's less than 3. Sorry, negative 3. So we can pick something like negative 4, it's less than negative 3. Negative 4 plus 3 gives us the negative value. Negative 4 minus 1 gives us a negative value, and the product of that gives us a positive value. Now, pick any value between negative 3 and 1, for example 0. 0 plus 3 gives us a positive value, 0 minus 1 gives us a negative value, and the product of that gives us a negative value. In our third range, any value greater than or equal to 1, so we can pick 2. So 2 plus 3 gives us a positive value, 2 minus 1 gives us the positive value, and the product of that gives us the positive value. So which range satisfies this inequality? Greater than or equal to 0. So we are picking the positive ranges. This and this. So the range of solution that will satisfy, or the range of values that will satisfy inequality is x such that x is less than or equal to negative 3 and x is greater than or equal to 1.